Wanju! Hello and welcome everyone to our very first Mission Space Virtual Excursion, Enigmatic, Earth and Space. My name is Ryan and this is my friend Laura.
And we're from the SciTech Discovery Centre. We're broadcasting to you from Bulu, Perth.
And as such, we would like to respectfully acknowledge the Whadjuk people of the Noongar Nation, traditional owners of the land that we're broadcasting from.
We'd also like to acknowledge the Aboriginal and Torres Strait Islander peoples from all across Australia and pay our respects to their elders past and present. We would like to acknowledge them as the first scientists in Australia, and we value their knowledge as engineers, innovators and problem solvers.
Now you're joining us from all around Australia today, which is fantastic. We're going to briefly take you away from your classroom lessons through our screen right here to SciTech.
Isn't that cool? And we've got a big map where we've put all of you as little pins. Can you find yourself on the map?
So there's so many of you out there today. So we've got a few people helping us out behind the scenes. They're going to be changing our cameras, our special effects, and activating our live chat. So if you can get involved in the live chat, please do so.
And we've got so much in store for you today. We have science demonstrations, planetarium tours, expert interviews, and more. And we're hoping we can show you a little bit about how what you're learning at home or at school might help you decode the universe and launch you amongst the stars.
So today's topic is a pretty straightforward one. We're looking at Earth and space. So looking at how our planet tilts and orbits and rotates and how that changes weather patterns and so on and so forth. But humans have a lot more to learn in this space.
Yeah, so let's kick things off with something fun. Roll the tape.
We've driven our SciTech truck out to the Gravity Discovery Centre in beautiful Gin, Western Australia. We already know lots about Earth and space because humans have done some really cool experiments. Let's use a bowling ball to represent a meteorite. What do you think will happen if we drop our meteorite bowling ball from 45 metres in the air?
3, 2, 1.
Whoa, that was awesome!
Yeah, so you might already know what happens when a meteorite comes in contact with the Earth. Okay, so it's burning up through the atmosphere, and then if it's big enough, pow, it plummets, and we can use maths and science to predict the outcome of such an event. It usually leaves a big crater.
Yeah, but what about if it landed on something a little bit less earthly? Like, what if the planet was made of cardboard or foam?
That's a great question. Well, science is a process about asking questions, making predictions, and doing experiments. So why don't we take a moment to think, what would happen if, say, our bowling ball was to land on cardboard, something like foam, maybe even water? Any ideas?
I don't know. Might make a bigger hole?
Yeah, possibly. We've done those experiments, so check them out in this video.
First up, let's see what happens with cardboard.
3, 2, 1.
Now we're going to take a look at water.
3, 2, 1.
And to finish, dropping onto a foam-like material.
3, 2, 1.
Whoa, I didn't think that was gonna happen. I guess that's the great thing about science. There's always more you can learn.
And that's how we keep learning, keep asking questions and doing experiments to find out more. Now, we've got a very special guest to be interviewed today, Catherine Bennell-Pegg, okay, Australia's very own astronaut. She is ready to speak to us and we're very, very excited to speak to Catherine today, where we can learn some more of the things that Catherine has learned as part of her astronaut training. I'll see you soon. Hi, Catherine.
Hi, how are you going?
Yeah, well, thank you. Thank you for taking the time to talk to us.
Oh, I'm so happy to have the chance to speak with you.
So we have our first question.
Yeah.
Why did you want to be an astronaut?
Oh wow, well, becoming an astronaut, better yet, an Australian astronaut, is the culmination of a childhood dream come true. I first fell in love with the idea of wanting to explore space when I was very young. I used to like lying in my garden looking up at the stars, and when I learnt that some of those pinpricks of light were not just stars, but entire planets, entire worlds no one had ever seen up close before, I thought that going there would be the most incredible adventure. It's that same urge of curiosity and drive for adventure that many kids have. Perhaps some of those watching like to look under rocks for bugs or like to climb trees to look at the view. It's that same feeling that has led humans to want to explore and understand our world. But as I grew up and went to high school, I started to find science very, very interesting. I realized that so many mysteries remained to be unlocked, and I wanted to be part of helping to unlock that new knowledge. And now, having been a space engineer for about 15 years, I really want to also go to space for what it can do for us here on Earth. Our space is incredibly important for the way that we look after our planet and ourselves. It helps us make new medicines. And we go up there, us astronauts, to make scientific breakthroughs that you can't make down here on Earth with gravity and the atmosphere in the way. So as I've grown up, me wanting to explore space, the reasons have evolved and got stronger and stronger.
Wonderful. So what was your favourite part of astronaut training?
Yeah, well, astronaut training was as fun as you can imagine and as intense as you can imagine. And my favourite part was doing it as part of an astronaut class, as part of a team. I was part of a team called the Hoppers. There were 6 of us training from different countries, and we were there to all get through it together and to help each other out. And to be an astronaut today, basically you need to have a career in a STEM field first. So in my class of the Hoppers, we have a neuroscientist, an astrophysicist, a helicopter test pilot, a medical doctor, an aeronautical engineer, and me, a space engineer, which meant that all of us were really good at some subjects and less good at others. So we helped each other out. And it's important to have that humility and identify your strengths and weaknesses so you can ask for help when you need it. Being able to put in the effort is more important than talent alone, just like here at school.
Now, all these subjects, do they kind of sit by themselves or do they work together? Especially when you're working in a team, do you have to share knowledge and borrow from each of these different skills that you're learning?
Yeah, astronauts today are all-rounders. We have to draw on lots of different kinds of knowledge, but we're not alone. It's also a lot of teamwork. So we have the astronauts we're in space with. We have mission control on the ground, hundreds of people that are supporting us, and the scientists and engineers as well. So being an astronaut, you're just the visible tip of an iceberg of a big, big team of totally different kinds of professions and people from your country and other countries around the world. If you think of any job, put the word space in front of it, it exists. We need space nutritionists to support the astronauts. We need space biologists and space doctors. We need space fitness instructors. We need people that drive the trucks and the trains that move the rockets around the world and the ships. We need people that sew together the spacesuits and sew together the blankets that go around satellites. We need people that are looking after international law and go to the UN to make sure that we explore space responsibly and that we don't make too much space junk so people in the future can use space too. And the list goes on and on. So I would say to young people that want to work in space, pick a career you'd like, add space in front of it, and there's a role for you there.
How can I get involved in space projects at home or at school?
So if you like space, the first thing that I would suggest doing is read widely. There's lots of good magazines out there. I loved backyard astronomy with a hobby telescope and binoculars. I liked reading science books, so science is something I was really interested in. I really enjoyed reading about new inventions and how people come up with solving new problems. It's absolutely helping to decode the universe. Yeah, there was a quote from Carl Sagan that I heard when I was much younger that stayed with me, and it is, "The universe is within us. We are all made of star stuff. We are a way for the universe to understand itself." And I think that's so powerful, right? We are the means through which the universe can decode itself. We have the ingenuity and the tools and the curiosity to discover more about the universe. And so far as we know, we are the only living being that's ever had that. So what a responsibility, what a wonderful opportunity. And not just to have that knowledge for our own philosophy and sense of place, but to be able to use that to look after ourselves, our planet and our world is awe-inspiring, I think, and it's a pleasure to be part of that journey.
Thank you, Catherine. That was a great interview.
Oh, thanks. I had so much fun too.
Bye.
Bye.
How cool! You got to talk to an astronaut!
Yes, that was super exciting. Catherine was amazing to speak to, and hopefully we can share some more conversations with Catherine in the next couple of days. But some of the stuff that Catherine spoke about, I really wanted to highlight because I thought it was amazing. She mentioned that it's so good to be curious and read lots because that helps us to decode the universe. She also mentioned that she had an astronaut team called the Hoppers that all had their diverse strengths and weaknesses, and that helped them to get through astronaut training's challenges. But she also mentioned there's a whole bunch of other people working in the space industry, not just astronauts. There's space fitness gurus, for example, or space clothes makers.
Wow, that sounds amazing. Could you imagine being a space chef?
Ooh.
Or, I don't know, a space zookeeper?
Whoa.
What do you think you could do in space?
It's a good question. Maybe a space footy player.
Oh yeah.
Let's put that question in the chat. Now we've got another astronaut who wants to talk to you all, Dottie Metcalf Lindenberger. Okay, very, very excited to be speaking with them. They are going to be transmitting to us from the USA at the very end of the session. Okay, so stay tuned for that.
What's going on?
I don't know. It looks like we're being interrupted.
Oh, hang on a second. I think I know what to do.
Oh, I've got to help out over here.
Whoa, it's an alien. I don't think I understand you. I don't think we speak the same language.
Hello, my name is Zog.
Oh, hello, Zog. I'm really sorry. You're actually interrupting a really important broadcast. We've got all the kids from across the country who are learning about space science.
I know I'm interrupting the broadcast, and I'm going to keep it interrupted until you can answer me these questions 3.
Oh, okay. I hope you've all got your brains switched on, everyone.
Well, how long does it take the Earth to revolve around the Sun?
Oh, good question. I think it was either 365 or 365 and a quarter. Can you help me out, everyone? If you think it's 365, put your hands on your head. If you think it's 365 days and a quarter, put your hands on your hips. How are we going? Oh, all right, I've got it. It's 365 days and a quarter.
Oh, drat. I bet you won't be able to answer the second one. Which celestial body goes further away from the Sun? Is it the Earth or the Moon?
Oh, if you think it's the Earth, everyone, make a really big Earth with your arms. If you think it's the Moon, make a little moon with your hands. Oh, okay, I've got it. They're saying it's the Moon.
Oh, the Moon. Yes, I guess you are right. Well, the third question, this is a hard one. I bet you won't be able to get it. How many times larger is the radius of the Sun compared to the Earth?
Oh, I think it was either 109 times or 10 times. If you think it's 109, put your arms up really high. If you think it's 10, put your fingers out to make 10 in front of you. Oh, I think I've got it. Yes, I can see. It's 109 times the size.
Oh, well, you haven't seen the end of me. I'll be back.
Okay.
Oh, gosh, well done.
Well, there were some tough questions.
Yeah, did you get all those questions right? I think I might need to do a bit more research in case Zog interrupts our broadcast again.
Yeah, speaking of research, something that I've been wanting to learn a bit more about is the vacuum of space. Like, what is it actually like? If we were to put something out there, what would happen? Like, what would happen if you put a marshmallow out in space?
Well, that's a great question. Luckily, a friend of ours, Evan, is currently in the SciTech lab, and they prepared an experiment possibly exploring just that. They've got some experiments that will show that you can do space research, not necessarily in space. Hi, Evan.
Hello friends and fans, welcome to the Science Theatre. My name is Evan and today we're going to be doing an experiment with an empty box. Except this box isn't actually empty. It's full of air. That just won't do. We need to get a completely empty box for this experiment and I've got just the thing. This here is a vacuum chamber. It is a sealed box with a nice big pump attached to it that can pump all the air out of it and make an empty space, well, as close to empty as we can manage without actually being in space. So what we're going to do is put a few objects in this vacuum chamber, turn on the pump, suck all the air out, and see how various everyday objects respond being placed into the vacuum of space, or as close as we can replicate here. Sounds like a plan. So, the first thing I've got is a marshmallow. Now, marshmallows, light, fluffy, full of air, perfect victim for this experiment. So we're going to put one in this empty chamber here and the other in this empty chamber here. So, what do you think is going to happen to the marshmallow when I turn on the pump and suck all the air out of this chamber? I want you to put your guesses in the chat, all right? Let's do it. So the pressure is decreasing in here as the air is pumped out of this chamber. And I can see that the marshmallow has doubled in size by now. And it's still getting bigger. Incredible stuff. The marshmallow just keeps getting bigger and bigger. Ah. And now it's started to deflate. Wonder what happened there. Let's equalize the pressure. And my poor little marshmallow has turned into a shriveled little thing like that. You see, marshmallows are full of air, and when we take all of the air out of this chamber, the air that's inside the marshmallow swells up and takes up more space. Eventually, though, it bursts, pops all the little air pockets, and starts to deflate again. We can show you exactly what's happening with one of these. It's just a little balloon, the end's tied off, got a little bit of air in it, and it should do something similar to our marshmallow. So I'll just get this set up, and we'll turn on the pump again, and I want you to watch the balloon as we take the air out of this chamber. So, the balloon has air inside it, and that air is always pushing out against the air that surrounds us and is trying to crush us. We call that the atmosphere. But once you take all of that air away, there's nothing pushing down on that balloon. So all of the air inside the balloon pushes out harder and harder, and that balloon gets bigger and bigger as it starts to take up more and more space. And without actually adding any air to the balloon, it's still sealed, but that balloon has doubled or tripled or quintupled in size, just like that. There is as much air in this balloon now as there was when I turned the pump on. And there's still just as much air in the balloon when I do this. Exactly the same as what we had before. It's incredible to think how much the atmosphere impacts how things behave here on Earth. Now, I'm under a lot of pressure to get this done in time, but I think we've got one more little thing we can do. A glass of water. What could possibly happen to this? There's no air pockets in that, are there? Well, there might be a few little bubbles of air. It's not sparkling water, but there might be some gases dissolved in it. So we're going to turn on our vacuum pump, and we're going to see what happens to a glass of water when we put it in a vacuum. Now you can see a bunch of bubbles forming on the inside of that glass, and as those bubbles are starting to rise to the top, it looks a bit like this water is starting to boil. which is very, very strange because boiling normally requires us to heat water to 100 degrees. But all we really have to do is make the pressure inside the water bigger than the pressure outside. And we can either do that by heating the water up a lot, or we can do it by removing the pressure around the water until eventually that water will spontaneously begin to boil. All right, I think that might be the boilingest we're gonna get our water. So I'll equalize the pressure and let's see what happens. Wow. So all of that water that came out of there was our boiled water that went into the atmosphere of this chamber and has then spilled all through here. Now you wouldn't want to do this with any other boiled water. We didn't heat it up. We just boiled it by changing the pressure around it. So I've made myself a bit of a mess, which means I think it might be time to say, back to you in the studio. That's all from me.
The water was boiling even though it was still at room temperature.
Yeah, I really like that bit. And the marshmallows too. It looked very tasty. Yeah.
Yeah, it was cool to see how you can do space experiments even though we're not in space.
Yeah, and you could probably do an easy space experiment as well. I want you to think, imagine our whole solar system was shrunk down. The Earth will be shrunk down to the size of a cherry tomato. If the Earth is the size of a cherry tomato, how big do you think another planet will be? Let's say Jupiter. How big do you think Jupiter's going to be? Any ideas?
I don't know. Maybe the size of an apple?
Well, it'd actually be the size of a watermelon.
Whoa, I guess Jupiter is the biggest planet in the solar system. Maybe we could put some more fruity planet questions in the chat.
Yeah, good idea. And maybe we can create a whole solar system of fruit and vegetables. But besides yourselves, there's actually a whole group of other people out there doing some amazing space experiments right here from planet Earth.
Yeah, we're about to head on over to talk to Georgia Dallimore. She's an Australian space, she's from the Australian Space Discovery Centre, ready to have a chat to us.
Yeah, they're just over this way. I'll see you soon.
Hey, Georgia.
Hey,
Thanks for joining our interview.
thank you. Thank you for having me here.
What is your dream job?
So I just graduated from university last year in aerospace engineering and computer science. So for me, my dream job, I have no idea yet, but I'm working towards it. I have a job right now that I love at the Space Discovery Centre. Part of what we do at the Australian Space Discovery Centre is talk about all of those many careers that make up being in the space sector. Because you think about an astronaut and the types of missions that they go on, just like being on a movie set, you have actors and directors and producers, and it's exactly the same for a space mission. You have astronauts, you have people in a mission control center, you have the scientists who design the experiments, the people who do the filming and the editing of all of the lessons that the astronauts might talk about or give on an International Space Station, for example. So all those people are really, really important to the space sector. And so we like to talk about those different pathways too.
Fantastic. So with all those different pathways, I'm assuming it's not all just about one thing or another. You have to learn lots of different things.
Yeah, space is a very multidisciplinary field. So me, for example, I like maths and I like science, but I really love music and I really love English. And I studied those things while I was in high school alongside doing the maths and science subjects. And that's really important because if everybody studied the same things, then how is that going to give different perspectives, especially on missions that, a lot of space missions are to do with the human body and human health and life sciences. And so we need to draw on lots of different points of views to make those missions a success and to have an impact back here on Earth.
Where do you think the space industry in Australia will be in 5 years' time?
I think for me, I'm really excited about the types of missions that we might see in 5 years' time. At the moment, we have Rover, the lunar rover, which is one of Australia's national space missions, and that is so exciting. So maybe in 5 years' time, we'll see Rover on the moon doing experiments on the surface, and then who knows what will progress from that. We have rockets that might be launching from Australia very, very soon. We have returns coming from space and landing in South Australia, for example. I mean, the last 5 years of our space sector have been so exciting that I can't even begin to imagine what the next 5 years are going to look like. And who knows what you'll get to be a part of as a student. You might get to work on a lunar mission, maybe a Mars mission, maybe something going to low Earth orbit, or maybe a piece of space tech that is doing something for here on Earth as well. I think there are so many possibilities at the moment, so I couldn't even pick one single thing.
Could you pick one single thing that you found the most inspiring, research-wise or space mission-wise, that you think was something that was really exciting for you?
Oh, for me personally, when I was in my internship in university, I got to work on a lunar payload, which is a little seismic sensor. And that means it listens out for moonquakes on the lunar surface. So
Like an earthquake, but on the moon.
exactly like that. So like little micrometeorites or bits of space debris that impact the moon, it creates quakes on the surface. And so getting to work on that as a student was absolutely incredible. And I think about what else I might get to do in the future. And same with students all around Australia right now.
Have you got any advice for young people who want to be involved in STEM?
Yeah, I think say yes to opportunity that comes your way. Once I got into the groove of saying yes to things, even if I was a little bit scared or I was a little bit unsure about where it would take me, it's led to some incredible opportunities because the doors just keep opening. After you say yes once and then you find out what happens, you say yes to something else and yes to something else, and then it just keeps snowballing. And that's led me to have an amazing career just after finishing university, and I'm about to go on this other amazing journey, and it all happened because I said yes to opportunities that came up. And I was a little nervous about them every single time, but they always worked out and they were always incredible experiences. Say yes to opportunity and follow your passions. Don't ever be afraid to follow what you love. And have curiosity as well to learn and to have passion and to have that open-minded nature of working with other people and learning from them and using that to build on your own experiences.
Thank you, Georgia.
Thank you very much.
We'll catch you later.
See ya.
Wow, that was amazing. So Georgia is a superstar space specialist that grew up here in Australia.
It's pretty amazing what you can do in Australia in the space agency, in the space industry, in fact. It was really great to talk to them about what they thought the space industry would be like in 5 years' time.
Oh, Zog's back again.
Again. Oh, this is going to be a problem, isn't it?
I am back, ready to interrupt your learning.
Oh no, everyone, we've got to turn our brains on again.
Well, you know the story. Answer me these questions. 3. Are you ready? What animal is the famous Aboriginal Australian Milky Way constellation? Is it the dark emu, or is it the dark kangaroo?
Everyone, if you think it's the dark emu, put your hand up like an emu. If you think it's the kangaroo, can you hop like a kangaroo? What was it? Oh, yeah, okay, I got the answer. It is the dark emu.
Oh, how dare you? Well, second question. Which of the following celestial bodies, we're doing celestial bodies again, celestial bodies in your solar system produces 384 yottawatts of energy per second to Earth?
Well, it would have to be either the sun or the moon. So if you think it's the sun, make a really big sun with your hands. If you think it's the moon, make a little moon with your hands like this. What are you doing? Can't see you there. Oh, yeah, okay, it's the sun.
Oh, well. Question 3, and I know you won't get this, all right? You ready? Which space equipment helps scientists better understand natural disasters on Earth?
I guess it would have to be either a telescope or a satellite. If you think it's a telescope, make a telescope with your hands. If you think it's a satellite, float around in a circle like a satellite. Let me have a look. How many telescopes? How many satellites? Oh, okay, I've got it. It's a satellite.
Oh! Okay, you got it. 3 questions, but I'll be back, I swear.
Okay, we did it, everyone.
Oh gosh. Well, we thought they'd be back.
Yeah.
At least I'm learning something new every time.
Yeah, absolutely. And you know, I learned something new the other day. Did you know that in Australia, we actually helped with the Apollo 11 missions, where we sent humans to the moon for the very first time? They had tracking stations here in Western Australia and in ACT as well, and they were communicating with the astronauts as they were landing on the moon.
That's incredible. I guess Australia has been doing stuff in the space industry for a long time, but there's never been a better opportunity to get involved than right now. Our friends at the Australian Space Agency were telling us some amazing things that are happening, including they're planning to send a rover called the Rover to the moon. It's about the size of a small suitcase, and it'll be collecting rock samples to see if there's any oxygen inside those materials, which is pretty amazing. There was also another project where they were creating spacesuits to help astronauts stay nice and strong and healthy, and helps with the muscle and bone density as they're moving around in microgravity.
Wow. Yeah, I think I heard about another one as well where they're using traffic management systems to track satellites and space junk and help to avoid collisions and tell people to get out of the way.
Yeah, it's amazing the amount of different things that we can achieve here in Australia. Speaking of, we've got another friend of ours, Angie Wazowski, who'd like to speak to us about some of the things that they're working on. We'll talk to you soon. Oh, hi Angie.
Hi Ryan.
Thank you for joining us.
Thank you for having me.
Let's get started.
Yes. So what got you interested in space?
So I've always loved space. I've been obsessed with space since I was little. I loved learning about the stars, about the moon, about the sun. But I didn't think space could be a job. I didn't think I could actually do it as a living. So I kind of kept my options open. I really loved histories. I thought maybe a historian. I loved politics, maybe a lawyer. I really liked planes, but I wasn't a super big fan of being a pilot, so I was like, what about air traffic controller? I have a fun little story of I used to talk to the moon and to the Orion constellation as my best buddies in primary school. Once I got into high school, so I got the privilege to go all the way to the United States of America. So I got the opportunity to visit Huntsville, Alabama, and actually try out being a bit of an astronaut here on Earth. And I realized that's not for me. But I also got to do so many other things on that camp and figure out that space is definitely where I want to be.
Now, you mentioned Orion as one of your favorite constellations. How can we see Orion in the night sky?
The way that I learn, I think is the easiest way to see Orion, is by first looking for his belt. There's 3 stars that make up his belt. Then on the side, you'll see 3 more stars that kind of point down, and that looks like his sword. And then when you'll see 4 stars kind of in the corners, and that's his shoulders and his legs. So then you can see Orion in the night sky with his shield and his sword ready for battle.
You're now doing your PhD in solar storms. Yeah, the difference between a storm here on Earth and a storm in space.
They are very different. They're quite different things, but I'll kind of put them in context with one another. So the sun is constantly blowing off what we call a solar wind. So it's a kind of think of it as like a cool summer breeze. It's really calm and it just kind of blows off when it's really nice. But once in a while, the sun is really, really aggressive sometimes, and a storm will erupt, and a bit of the sun's atmosphere will get flung out into space at 10,000 times the speed of a race car. But it's not really a storm like here on Earth. It's not like thunder and lightning and rain. It's more like a really, really big gust of wind. And when that big gust of wind flies out into space, it can interact with planets such as Earth.
So can we use the information about space storms to better understand storms here on Earth?
It's a bit tricky because space storms are really different from Earth storms, but you can study space storms to track them as they move through space because it's really important for Earth. So the way that I track them is I use the wonderful antennas here to actually look at how galaxies will twinkle as the storm passes across to see where the storm is, to see what it looks like. And it's really important to track them so we can predict them. So when a storm hits Earth, we get our beautiful auroras. So the aurora borealis and aurora australis, that's the storm hitting and washing over Earth and causing our poles to light up in beautiful blues in the north, and we have reds here in the south.
Can these solar storms impact things like satellites?
Yeah, they absolutely can. So in the same way that they can cause the auroras, they can cause issues on satellite circuitry. So it can cause the satellite to go a bit haywire. It might cause it to shut down and even deorbit. So that means literally fall from the sky.
It sounds like solar storm can be quite harmful to technology. Is it dangerous for people?
Oh, not at all. We're completely safe. Anything with a circuitry, so if you're a robot, then maybe you might be a little bit in trouble. But if you're a person, absolutely nothing.
Can anyone be a space scientist?
Of course anyone can be a space scientist. If you really like space, if you really like solving puzzles, then absolutely become a space scientist.
Well, thank you very much, Angie. I had a great time.
Thank you for having me, Ryan.
We'll catch you later.
Bye.
So isn't it amazing how we can learn from these space professionals? And the more we learn from all these people doing this amazing research, the more we can understand the universe, decode the universe, if you will.
Yeah, I reckon lots of people watching probably already know quite a bit about our amazing enigmatic Earth and its place in the solar system.
Yeah, spot on. You might be learning about stuff like weather patterns or the day-night cycle, things like that.
Yeah, in fact, we have an amazing planetarium here at SciTech, and we'd like to take you on a tour. So our friend Leon is already, he's got some really awesome presentations prepared for you. Here you go.
Hello everybody, welcome to the SciTech Planetarium. My name is Leon, and today we are exploring our enigmatic Earth.
This is Earth. It's beautiful, isn't it? It spins around once a day, giving us day and night. This arrow shows the axis of rotation that the Earth spins around. Here is Earth's orbit around the Sun. It shows how our planet moves over the course of a year. Notice that Earth's rotation axis is tilted to its orbit? See how it's not straight up and down? This means that as we go around the Sun, different parts of the planet get more or less sunlight depending on the time of year. Right now it's winter in the Southern Hemisphere, and you can see that the Southern Hemisphere is pointing away from the Sun. If we fast forward to January, the Earth moves around to the other side of the Sun, and the tilt points the Southern Hemisphere towards the Sun, and it's summer in Australia. Another 6 months later, and we're back to winter again. You can also see that when the Southern Hemisphere points away from the Sun, the Northern Hemisphere points towards it. And that's why the seasons are opposite in each hemisphere. Earth has a thin atmosphere. It's only 100 kilometers thick. Above 100 kilometers, and you're in space. If you've ever traveled for 1 hour down the freeway, you've traveled the same distance that it takes to get to space. Space is much closer than you think. If we look down beneath our feet, we see Earth has a rocky outside called the crust, and underneath the crust there are different layers of rock as we go deeper. In the middle of the Earth is the core. Electricity flowing around the core creates a strong magnetic field that surrounds our planet. If you've ever used a compass to point the way north, you're making use of Earth's magnetic field. The magnetic field helps our compasses point the right way, and it also protects us from the sun. The sun gives us daylight, but it also throws lots of hot gas at the Earth. We call this the solar wind, and the solar wind is very dangerous to humans, but our magnetic field catches the solar wind, stopping it from harming us. And by the time the solar wind reaches Earth, it's not dangerous anymore. All it can do is gently bump into the atmosphere, causing it to glow. When the atmosphere glows, we call this an aurora. And auroras are some of the most beautiful natural phenomena we've ever discovered. And so now you know, when you see an aurora, you're looking at the connection of the core of the Earth, thousands of kilometers below our feet, and the sun, millions of kilometers above our head. We're all connected together by our dynamic, enigmatic planet Earth.
Oh, wow, thanks Leon. I love planetariums.
Yeah, me too. And you can learn a lot from going to these places like planetariums, schools, science centers, libraries, museums, discovery centers, so on and so forth. Yeah, there's always more you can learn.
Oh, Zog's back again!
Oh my gosh.
I'm back. I told you couldn't get rid of me that easily.
Again? You're back, Zog?
Yes, and you know the deal. I'm going to be asking 3 questions, and you need to answer them. Otherwise, I'll keep you locked here forever. Alright. Which planet is nearly Earth's twin in size and mass?
Oh, I think it's either Mars or Venus. If you think it's Mars, shake your head like this. If you think it's Venus, nod your head like this. Oh, okay, I've got it. It's Venus.
Oh, that one was an easy one. These next 2 won't be so easy. How long does each season last on Neptune?
Neptune, is it, I think it might be 40 years or 3 weeks. If you think it's 40 years, put up a big number 4 with your hands like this. If you think it's 3 weeks, do a number 3. Oh, this one might be a bit tricky to tell. Oh, okay, I see. Oh, I got it. It's 40 years.
Oh, how do you know that? Oh, well, this last one, you'll never guess because you're from Earth. Which planet has the largest volcano in the solar system?
Oh, okay. I think it's either Mars or Jupiter. If you think it's Mars, put your arms out like this. If you think it's Jupiter, put your arms across like this. Oh, okay. I've got it. It would be Mars.
I'll be back.
We did it, everyone! Those were some tricky questions, but I saw some people got all the answers correct, so good job, everyone.
Well done. Well done. I wonder if Zog will be back tomorrow in our cryptic chemistry session. But before we look at that, let's think about some of the stuff we covered today. We got to speak to Catherine Bennell-Pegg, Australia's very own astronaut, which was amazing to hear some of their experience. We also got to speak with Angie and Georgia about what they're learning on their journeys in the Australian space industry. We also spoke to Evan and Leon about some of the amazing presentations that they've prepared for you all too. So it was a very amazing experience.
Yep, and of course, we were challenged by Zog.
Of course, definitely challenging my patience, interrupting our broadcast. But the main takeaway I'll take from all of this is that space and science is for everyone. Curious minds of all kinds can find their place in the space industry, not just being an astronaut, okay? We can build on the stuff that we're learning in school to make discoveries in space that will benefit life here on Earth as well.
Yeah, thank you so much for joining us today, everyone. We hope you've had a bit of fun, and we hope you can join us again tomorrow for our next session.
Before we say our final goodbyes, we've got one final little bit for you. Dottie Metcalf Lindenberger is transmitting all the way from the USA. Retired NASA astronaut, has a very special message for you all. So I'm going to go set that up now.
Enjoy. Thanks for joining us, and we'll see you tomorrow. Bye.
Hello, hi, I'm Dottie Metcalf Lindenberger. I'm a retired NASA astronaut. I flew to space before you were born. I flew in April of 2010 on a space shuttle to the International Space Station that continues to grow and do amazing things. When I was little, I wanted to be lots of things. I was a very curious kid, but my parents were both into science and math. So we would go to museums, and I was really curious about space, more so like planets and stars. And then I found out that Sally Ride was flying in space. And so I realized, hey, it might be possible that an American girl could grow up and be an astronaut. So from about the 3rd grade on, I wanted to be an astronaut. I didn't really know how you got to go to space. Like, what do you have to study? What do you have to do after school and go to college? You know, what do I do to become an astronaut? So it would take time for me to really realize what it would take to become an astronaut. But yes, I wanted to do that, but I also really love Earth. And so I also was interested in doing a job like geology, which is what I also majored in college. When astronauts come into being an astronaut, they actually join a team. And so I joined my crew team, and that was another 6 other people. But really, it's more than 6 people. It's all the people that train you, and it's all the people that work during your mission, like the people in the mission control, the engineers, and the scientists. So on our flight, we had this tricky problem with installing an ammonia tank. This ammonia tank is huge. It's like the size of a refrigerator, and it had just 4 bolts, and those bolts weren't going in as we had practiced in the water and as we had planned. And so it took the team on the ground realizing it's because our ammonia tank is being unevenly heated. Some of it's in bright sunshine, some of it is in dark shadow, and that's causing it to warp. And so they figured that out, and then they helped us solve how to get it into place. But that set back our spacewalk. And so that same team on the ground helped us complete the rest of our series of spacewalks in a logical way. So it goes into teamwork, really. And right now, if you think about it, you're in a team, right? You're in a team of classmates learning. You might be in clubs or sports. You are in multiple teams, and it takes teamwork to solve big problems. I hope that you are always curious about space, but no matter what, I hope that you work hard in your classes and learn lots about Earth and space, because I hope I've showed you today that they're really together. Like, we are on a spaceship, and that spaceship is our Earth, and that we have to take care of it. And by understanding Earth, we can understand more about space, and then space can also help us understand about Earth. So be curious about it, keep working hard and challenge yourself in your classrooms, and have the courage to go after your big dreams like I did with being an astronaut.
You haven't seen the last of me.